endocrine system last week, and we're going to continue on with that. We're going to continue on with the endocrine system. Now, the endocrine system is where your hormones are generated.
Oops. I think somehow we just lost David. Maybe let David connect back us again. Let me pause it. So welcome, Celine. If you can say hi, I would love to chat with you a little bit, waiting David to come back. Or take a look.
I'm actually still technically on the clock at work, but I'm done with all of my work, so I'm paying attention, but
okay,
I'm not supposed to be on my phone right now, so.
All right. Well, anyway, welcome you. Where you are connecting from?
I'm in Columbus, Ohio. I'm actually Dave's granddaughter, I guess, step-granddaughter. So
Granddaughter.
I'm Mickey and JD's daughter. I'm JD's directly and Mickey is my stepmom.
Oh, that's the relationship. That's awesome. Oh, we see David come back.
Yeah, I came back. I'm not sure what happened to there, but I'm glad to be back. And what I was doing was doing an orientation of where we were to where we're going, and we were talking about the endocrine system. Now, the endocrine system is the system that in your body that generates your hormones. Now, many people refer to just a couple of hormones as to being the only ones that they talk about, but right now, each one of you has over 50 hormones working in your body right now, sometimes in conflict, sometimes in coordination, working to continue your homeostasis, which is life. You know, the word homeostasis is it basically means life to you. So you have your nervous system, your endocrine system, and your immune system. And today we're talking about the endocrine system. We have touched upon the immune system in the past. We will touch upon the nervous system a bit into this presentation as well as later on into the year. But right now, the endocrine system is the slow motion of your body generating the activities that your cells need to have. Now, there's a lot of interactions associated with it. We have major glands that generate our hormones. The hypothalamus, which is in your brain, which connects your nervous system and your endocrine system together. The homothalamus then sends most of the signals to the other glands to generate hormones. Okay, so what I want to do is to go right into that presentation. And I want to share my screen. Okay, so this is today's presentation. We're going to go back in to cover a lot of information that we covered last week, because it's a very, very complicated process. So generally speaking, we're going to talk about Anatomy 101. This is basic stuff. We're going to talk about the glands, what they do, and then looking at the purpose of the presentation is we're looking to live happier, healthier, and more fully. Now, the component of the endocrine system is it's got a lot of moving parts. As I mentioned, there are at least 50 integrated hormones working in your body right now. So if you want to consider this like a huge Sudoku, right? The most complicated Sudoku you could ever think of, and then I want you to change it to make it, instead of 3 boxes of 3 cells, you did 9 boxes of 9 cells. Then what I want you to do is make it 12 boxes of 16 cells. All right. And now I want to make it 3-dimensional, and then I want to make it 4-dimensional, which make every cell change with time. And now you have a picture of the complexity of the hormonal system, or what we call the endocrine system. Now, this is a picture of what's going on inside of your body. Go back to that. And relating to the relationship between cholesterol and your corticosteroid, androstenedione, your progesterone, your androgen, your testosterone, all tied together. And one of the components of this is that you're going to see down here in the pink, that's where a transition that takes place in your mitochondria. Now, we've talked about mitochondria as it relates to USANA products because of the cell signaling configuration, because we can now talk across our cellular boundaries to reach our mitochondria to cause it to renew itself and to create, and your mitochondria is your energy factories in your body. So we can create new mitochondria from old mitochondria, we can renew old mitochondria, and we can also generate an awful lot of antioxidants inside of your cells. It's basically where you need them the most. The components of the chemical changes between one factor and another factor are just highlighted here. For instance, I'm going to go to cholesterol to progesterone to androgens to your testosterones. And interestingly enough, just to spice things up just a little bit, is that there are no sex hormones. Okay, or there's no male sex hormone or more female sex hormone, because males need estrogen and progesterone just as much as women need testosterone. It's just the difference between the amounts in your bodies that make us that difference. Now, the endocrine system is a series of glands in our bodies, and these glands then secrete chemicals known as hormones. And the endocrine glands include the brain, the heart, the lungs, the liver, the skin. So they all get controlled by these hormones. So we can see some of the main glands: the hypothalamus, the pituitary, the thyroid, the parathyroid, the thymus, the adrenal glands, the pancreas, the ovaries, and the testes. In the surrounding thing, they're not pretty, but they are very, very important to us. And the nervous system and the endocrine system, if you can see this little red X right here in the center of the brain, or to the base of the brain, that's pretty much the location of the hypothalamus, which sits on top of the pituitary gland and then generates signals to the pituitary gland, frontal and rear lobes, which then send signals out, let's say, to the thyroid. Now, I have some videos set up that will help explain all of this. The first one here is just about 5 minutes long. And Mila, we need to make sure that the can hear this.
Wanted to work for yourself and have a business to run from anywhere in the world. Believe it or not, it's a process.
Hey, David, we cannot see
system is one of the two
video
systems
playing.
that are responsible for communication and
All right, hang on.
integration between various body tissues, the other being the nervous system. Endocrine communication is
Can you
achieved
see it now, Mila?
chemical messengers
Yes.
called hormones.
Okay.
Hormones are produced
Can you
in
hear it?
endocrine glands
Yes,
and secreted into the
but the
bloodstream,
volume are really low.
travel wherever the blood goes. But it can only affect cells that have
So do you
receptors.
remember the how to make it like merge the audio so we can hear better?
For cholesterol,
Well, that's what I was
and
looking
are
for
lipid-soluble
before. Hang on. Oh, go ahead.
non-steroid hormones
We're gonna.
peptides or amino acids and
Hang
are
on.
water soluble. Lipid-soluble steroid hormones can
Hang
cross
on
the
for a
cell
minute.
membrane to bind to their receptors inside the cells, either in the cytoplasm or nucleus. Hormone receptors are typically transcription factors. Upon forming, the hormone receptor complex binds to specific DNA sequences to regulate gene expression. Hormone can travel wherever the blood.
All right.
Very
So,
good.
yeah, Mila, the last time I went looking for it, it was in participants, but today I can't find it. Can you find it in participants?
Merge the
Or
audio.
stop recording, research, stop live.
No, the so basically on the top right corner.
Got it. Got
There
it.
you go.
I got it. Okay, I got it. So we're gonna go back.
Perfect.
The endocrine system is one of the two systems that are responsible for communication and integration between various body tissues, the other being the nervous system. Endocrine communication is achieved by means of chemical messengers called hormones. Hormones are produced in endocrine glands and secreted into the bloodstream to reach body tissues. A hormone can travel wherever the blood goes, but it can only affect cells that have receptors for it. These are called target cells. There are two major types of hormones: steroid hormones derived from cholesterol and are lipid soluble, and non-steroid hormones derived from peptides or amino acids and are water soluble. Lipid soluble steroid hormones can cross the cell membrane to bind to their receptors inside the cells, either in the cytoplasm or nucleus. Steroid hormone receptors are typically transcription factors. Upon forming, the hormone receptor complex binds to specific DNA sequences to regulate gene expression, and thus mediating cellular response. On the other hand, water-soluble non-steroid hormones are unable to cross the lipid membrane and therefore must bind to receptors located on the surface of the cell. The binding triggers a cascade of events that leads to production of CAMP, a second messenger that is responsible for cellular response to hormone. It does so by changing enzyme activity or ion channel permeability. Major endocrine glands include the hypothalamus, pituitary gland, pineal gland, thyroid and parathyroid glands, thymus, adrenal gland, islets of the pancreas, and testes in men or ovaries in women. The endocrine system also includes hormone-secreting cells from other organs, such as kidneys and intestines. Except for the hypothalamus and the pituitary, different endocrine glands are involved in different, more or less independent processes. For example, the pancreas produces insulin and glucagon that keep blood sugar levels in check. The parathyroid glands produce hormones that regulate calcium and phosphorus. Thyroid hormones control metabolic rates, while the ovaries and testes are involved in reproductive functions. On the other hand, the hypothalamus and pituitary gland play a more central, integrative role. The hypothalamus is also part of the brain. It secretes several hormones called neurohormones, which control the production of other hormones by the pituitary. Thus, the hypothalamus links the nervous system to the endocrine system. The pituitary is known as the master gland because it controls the functions of many other endocrine glands. A major role of the endocrine system is to maintain the body's stable internal conditions, or homeostasis, such as blood sugar levels or serum calcium levels. To do this, it utilizes negative feedback mechanisms, which work very much like a thermostat. The heater is on when the temperature is low, off when it's high. For example, when blood glucose level is high, such as after a meal, glucose induces insulin release from the pancreas. Insulin helps body cells consume glucose, clearing it from the blood. Low blood glucose can no longer act on the pancreas, which now stops releasing insulin. Another example is the regulation of thyroid hormone levels, which are induced by a pituitary hormone called thyroid stimulating hormone, TSH. TSH, in turn, is under control of thyrotropin releasing hormone, TRH, from the hypothalamus. When thyroid hormone levels are too high, they suppress the secretion of TSH and TRH, consequently inhibiting their own production. Thank you for watching. If you like our videos, be sure to check out.
Right. We're going to stop share right there just for a second and go through that just a little bit, because there's a relationship between our previous instructions and knowledge of our USANA products and what we just heard. Now, remember that we've got the lipid soluble and the amino acids, which are water soluble. And remember that when they talked about the amino acid hormone, it needed to enter into the cell at gates, right? It would lock up with the gate, and then there would be another hormone that actually transmitted to the inside of the cell. And if you remember correctly, is that as you get to too much insulin, it actually damages those gates, right? You get inflammation, and so the glucose cannot enter into the gate. So one of the components of diabetes is that they're always hungry, right? Because the cells are hungry, because they're not getting the glucose. So if the glucose can't get into the cell, where does it go? It goes into the fat. So remember that story? Remember all that education about diabetes? We did this from Elvin's house not that long ago. And did this presentation with Elvin, who suffers from diabetes. And we learned about that component. Now we're looking at it from that same issue from a different point of view. And now we're looking at it from the hormonal setup to be able to open those gates, or to be able to enter into the cell to help control it and to have it do what it needs to do. Okay, does anybody have any questions from what we just saw? All right, so what we want to do is go back and share the screen again, and we'll go back to the presentation. Okay, now with this next two groups, this is a part one and a part two. I love this guy because he covers a lot of information and he gets right to the point. You do need to pay attention because he does talk fast in order to get through the information in a very short period of time. So the first part is Endocrine System Part 1, the glands and the hormones.
Maybe you need to do the same thing.
I've invited you all here today because I wanted to talk to you about some ugly stereotypes that are going around. I've been hearing a lot of unfair, unseemly, and unscientific generalizations being made lately, and they mostly have to do with sex and your hormones. People have a nasty habit of equating hormones with a particular set of behaviors and conditions.
Yeah, we cannot see the video again. If you want to stop and re-share the screen again.
I can do that. I'll stop sharing the screen. And now I will go back to sharing the screen. Okay, can you see my gentleman there with his cadaver in the background there?
Yes.
All right.
Okay.
So Let's go back. There we go.
Going around. I've been hearing a lot of unfair, unseemly, and unscientific generalizations being made lately, and they mostly have to do with sex. And your hormones. People have a nasty habit of equating hormones with a particular set of behaviors and conditions, most of which have to do with reproduction or sexual development, or acts that include what my brother John has referred to as scootily pooping. For example, people will say that hormones are why Kevin has zits and is being all moody, or why Hannah, who's 3 months pregnant, just cried watching a commercial for car insurance, which, let's be honest, I do that too. Now, I'm not saying that hormones aren't at the root of sexual attraction or zits or occasional bouts of extreme emotion, because they are. That's just not all that they do. Not even close. When people talk about hormones in the context that I just mentioned, what they really mean is sex hormones. But sex hormones are just one kind of hormone that you have coursing through your body right now. In fact, there are at least 50 different types of these chemical messengers at work in your body at this very minute, but only a very few of them have anything at all to do with sex. The truth is, from birth to death, just about every cell and function in your body is under your hormones' constant influence. They're floating through your blood, regulating your metabolism, your sleep cycle, your response to stress, and the general and incredibly important overall homeostasis that keeps you not dead. Some hormones are just there to make other hormones trigger even more hormones in a kind of chemical relay race that biologists refer to rather elegantly as cascades. These hormones run through your body no matter what your mood is or whether you have zits. So the reality is, we are all hormonal, all the time. Okay, to begin to understand our hormones and the endocrine system that produces, releases, and reabsorbs them, we have to step back and take a broad view. Not just by emphasizing that sex hormones are not the only hormones you have, but also by looking at how your hormones interact with your other organ systems. Because if anything, your body has two bosses, two complementary systems that are constantly shouting instructions over each other to all your bits and pieces. Both your endocrine system and your nervous system are constantly trafficking information around your corpus, gathering intel, making demands, controlling your every move. They just have totally different ways of doing it. Your nervous system uses lightning-fast electrochemical action potentials delivered by an expressway made of neurons to specific cells and organs. But your endocrine system prefers a slower, wider stream of data. It secretes hormones that travel through your blood, not through neurons, so they move more slowly, but they also produce widespread effects that last a whole lot longer than an action potential. Now, compared to your heart or brain or other arguably more glamorous organs, your endocrine system's organs and glands are kind of small and lumpy. They're also rogues. Instead of being all nestled together like in your other organ systems, these guys are scattered all over the place, from your brain to your throat to your kidneys to your genitals. A gland is just any structure that makes and secretes a hormone, and the master gland in your body is the pituitary, which produces many hormones that signal other glands, like the thyroid, parathyroid, adrenal, and pineal glands, to make their own hormones. The endocrine system also includes a few organs, like the gonads, the pancreas, and the placenta in pregnant women, all of which have some other non-hormonal functions and are made up of multiple tissue types. And technically the hypothalamus in your brain is in the endocrine club too, since in addition to all of its busy brain duties, it does produce and release hormones. So thanks to all these glands and organs, you've got these hormones diffusing through your blood doing all sorts of different things, but the thing to remember about them is that a hormone can only trigger a reaction in specific cells. They're so-called target cells that have the right receptors for it. So just like some keys can open many locks while others only work with one, so too can the hormone-target cell relationship either be widespread or localized. You're probably going to want an example of that, so your thyroid at the bottom of your throat produces the hormone thyroxine, which stimulates metabolism and binds to receptors in most of the cells in your body. But your pituitary, which is nestled all comfy under your brain, produces follicle-stimulating hormone, which helps regulate growth and trigger sexual maturity, and it only targets specific cells in the ovaries and testes. So, how do hormones bind to their target cells? Well, chemically, most hormones are either made of amino acids, including their more complex structures like peptides or proteins, or they're derived from lipids like cholesterol. And this is key because a hormone's chemical structure determines if it's water-soluble, like most amino acid-based ones are, or lipid-soluble, like steroids are. Solubility is important because your cell membranes are made of lipids. That means that water-soluble ones can't get across them, so target cells for those kinds of hormones have receptors on the outside of their membranes. Lipid Lipid-soluble hormones, on the other hand, can just basically glide right through that cell membrane, so their receptor sites are inside the target cells. Either way, when a target cell is activated, the hormone alters its activity by either increasing or decreasing some of its functions, usually with the goal of maintaining your body's homeostasis in one way or another. So, if hormones are keeping your body in balance, what's putting your body out of balance? I don't know. Could I interest you in some pie? If you have a couple of nice, generous helpings of strawberry rhubarb pie, and just to make things interesting, let's say they're a la mode, your blood glucose level is gonna go through the roof. And the pancreas regulates your blood sugar by releasing two different hormones, insulin and glucagon. Once you have a belly full of that pie, beta cells in your pancreas release insulin, which helps lower your blood sugar by increasing the rate at which your cells store the sugar either as glycogen or as fat for later use. Now let's say you've done the opposite. You've eaten no pie. You're pieless. In fact, you've eaten nothing for hours. If your blood sugar drops too low, then alpha cells in the pancreas will instead send out glucagon, which helps raise your blood sugar levels, in part by decreasing the storage of sugar in your cells and triggering the release of glucose back into the blood. Lots of different endocrine-related illnesses, like diabetes or hyperthyroidism, tend to be the result of either hyper, too much, or hypo, too little secretion of certain hormones, which throw your homeostasis off balance. But there are lots of more common and less obvious ways your hormones can get out of balance, not because of some disorder, but because these signaling chemicals are just caught up in a chain reaction, which can take a while to subside. Some hormones just exist to control other hormones, which in turn control still more hormones. So as soon as one starts to trickle out, you can pretty quickly wind up with a cascade on your hands. You got a few different hormone cascades going on at any given moment, but one of the big ones, one that's really worth understanding, is the hypothalamic pituitary adrenal axis, or the HPA axis, because you don't want to have to say that every time. This is a complex series of interactions between three glands that ultimately regulates lots of your body's daily processes, like digestion, sexuality, immune response, and how you handle stress. And it's complex not just because of all the glands involved. It's also one of the more crucial instances of your endocrine system coordinating with your nervous system. Specifically, it's behind that fight-or-flight response that everybody keeps talking about. The HPA axis is essentially the endocrine system's companion to the sympathetic nervous system. The sympathetic system, in times of high stress, does things like speed up your heart rate and direct blood away from your digestive organs into the muscles. But many of the other effects of the stress response are carried out by your endocrine system, and getting your nervous and endocrine systems to work together in times of crisis is where the hypothalamus comes in. It's the hub of where the two systems meet. It keeps tabs on what's going on all over your body, analyzing your blood for signs that something might be off. So let's revisit our fight or flight scene from a few lessons ago, the old burning house scenario. So you're sleeping, you're dreaming about petting pandas with Emma Watson or whatever when the smoke alarm goes off. Well, action potentials in your brain trigger neurons in your hypothalamus to release the peptide hormone CRH, or corticotropin releasing hormone. The CRH makes the very short trip through the bloodstream to the anterior pituitary gland where, because it is water soluble, it binds to receptors on the outside of its target cells. There, it triggers the release of adrenocorticotropic hormone, or ACTH. The ACTH travels again through the bloodstream to the adrenal cortices of the adrenal glands on top of your kidneys. When the ACTH binds to receptors on cells in an adrenal cortex, it triggers the release of a frenzy of different freak-out compounds known as glucocorticoid and mineralocorticoid hormones. Typically, these hormones help us deal with day-to-day stress by keeping our blood sugar and blood pressure balanced. But under major stress, like waking up in a burning building stress, these hormones, like cortisol, cause the classic fight-or-flight response, ramping up your blood pressure, dumping glucose into your bloodstream, shutting down non-emergency services like your immune system and sperm and egg development. And guess what? Now that all these stress hormones are pulsing through your blood, the hypothalamus back in the brain senses them. And because its job is to monitor and maintain balance whenever possible, it then stops secreting CRH, which eventually causes the other glands to stop secreting their panic hormones. Now, because this element of the stress response is hormonal rather than electrical, it comes on more slowly than the nervous system part, and it takes longer to subside too, as those stress hormones linger in the blood before being broken down by enzymes. So, we're a long way from teenage crushes and zits and crying over commercials at this point, aren't we? As a lifelong owner of hormones, I hope you'll join me in dispelling the stereotypes that surround these powerful and important chemicals and give them the respect they rightly deserve. Today, we looked at the endocrine system and how it uses glands to produce hormones. These hormones are either amino acid-based and water-soluble, or steroidal and lipid-soluble, and may target many types of cells or just turn on specific ones. We also touched on hormone cascades and how the HPA axis affects your stress response. Thank you to our Headmaster of Learning, Thomas Frank, and to all of our Patreon patrons who help make...
All right. So we're going to stop and share just for a second there. Let's do a little reminder around and again, touch base with where we were, okay? First of all, you got a picture of where and the total number of glands that we have that interact with hormones. Can anybody say one gland? Everybody unmute.
It's really hard for me to say pituitary gland, right?
I was going to say that.
Okay, how about another one, Leonard? What's another one?
I'm scrolling through my notes here. Randy was talking fast.
You
Yes,
could
he
write
does.
while he was talking. Could barely hear him that fast.
Yeah. So what gland comes right to mind to you?
My thyroid.
Absolutely. Okay. What goes along with the thyroid? What's the other gland right on top of your thyroid?
That's David. I think God really likes you, David.
All right. So one key component with this, and we're going to touch more on it later, is the parathyroid, because it controls the movement of calcium in your body. Okay. And one of the reasons why I got involved in chasing down hormones, and it's almost been 2 years now that I started down this journey of discovery of trying to make sense of the hormonal components, was because we were trying to grow bone. Now, who remembers the video that I did, or the training that I did on growing bone?
Yeah, I do.
Okay. It's still on YouTube, folks. It's one of the most popular trainings that I have done. If you go to our YouTube's training site, you can still find it. It's still there in the component. And one of the important components of that is that we needed to grow bone very fast. And in order to accommodate dental implants. And I was working with a dental surgeon in Jordan, very, very famous guy named Basim Sadati. And Basim was the head of the Dental Implant Association for the country of Jordan. And I sought him out so that we could work together. And quite frankly, he became amazed by the products that we have, because he saw firsthand how fast they could work and how and that the fact that they did work. Okay. But the combination of, we needed to figure out what was the combination of things that we needed to do in order to grow bone. And we know that we needed calcium, and we knew that we needed to have the I want to say calcium. Thecla, help me out again. This is your favorite one. Got a brand new product in it. The pink drink that you don't like the color of, but you still need it. Hila? I want to say it's not cholesterol. It's
Collagen.
collagen. Okay. All right.
We stay together.
You know, I don't know that I have asked that question less than one time every week, and then I know that this is on top of Thecla's mind is that the need for collagen. So we needed to know that we needed both calcium and collagen, and we needed a signaling technique to get there, and it comes from the parathyroid. Okay, it's a hormone. So going back that path, the other component of it is that perfluoroalkyl C, right? What do we find with perfluoroalkyl C when we look at how we can prevent degenerative diseases? Is to control inflammation, right? Do you remember that your perfluoroalkyl C grabs up those antioxidants and gets them out of the body so that they don't create the inflammation? And one of the components of the inflammation was right there at those receptor cells, right? The target cells right at the receptors on those target cells. Now remember that, right? Now I know that Salem doesn't because she's brand new, and we're going to get back to picking up on the science of this. But then we look at, darn, we have those receptor cells. So the insulin, by definition, since it can't get through the, get the glucose through the cell without opening the door for it, in lock and key situation, that must be an amino acid, right? Because it has to have that receptor cell in order to open up the door. And then you say NFR2 to get across the barrier of the cell, it must be a what?
Soluble.
It must be a lipid, right?
Yeah.
It must come from the cholesterol. Isn't that fascinating? I mean, we're just making the relationship between what we already know and what we're learning. Okay. And coming back to the point is that one of the biggest components of the messing up of the cascades will come from the fact that we can't open the doors when they need to be open, or that we can't shut off with that negative reinforcing component and activity that's going on. And we're going to find that in the thyroid, okay, with the hypothyroidism. All right. So what I want to do now is go to the second video. I'm going to go back to sharing my screen. All right. And we're going to go to part 2.
Ever wonder how quickly you can launch an online business so you can start living your dream life? Believe it or not, there's a process and a formula for
Maybe you
launching.
need to do the same thing.
Got a case study for you. Let me tell you about Marie. She was a healthy woman.
I have to do the same thing again, Mila?
Yes.
Okay. Didn't have to do that last week. That's very, share sound. Okay, it's still showing share sound.
No, the
Okay.
video. The video you need to stop sharing and then share back again.
Oh, okay. All right. So put one on. I'm going to stop share. And I'm going to go back to share. And there we go.
For you. Let me tell you about Marie. She was a healthy woman in her late 30s. She'd always been an active person, but at some point her energy level just seemed limitless. She was walking the dog 4 times a day, up at 5 in the morning, emailing her coworkers, and at midnight she was still awake, like dusting the ceiling fans. At first she felt great. She was super productive, but soon she started having trouble sleeping. She felt anxious all the time. She lost a lot of weight and noticed that she felt hot and sweaty when no one around her did. She started experiencing heart palpitations. Then one day her vision seemed blurry, and when she looked in the mirror, she was kind of surprised to find that her eyes were actually bulging out of their sockets. So yeah, she finally called a doctor because, bulging eyeballs. Marie's doctor referred her to an endocrinologist who, after running some tests, determined that the root of her problems was in her thyroid gland. The thyroid is one of the stars of your endocrine system. It's the little butterfly-shaped structure located anterior to your trachea and inferior to the larynx or voice box. It may look cute and unassuming, but don't be fooled. The powerful hormones that it produces influence some of your most important physiological processes. These hormones, and many others, help maintain your chemical homeostasis, the balance and concentrations of substances like calcium, sodium, even water within very narrow ranges so that your body can provide a consistent internal environment for your cells. Your cells and the proteins in them need that stable environment to function, so if your body loses its homeostasis too dramatically, cellular function will stop, and as we say here on Crash Course Anatomy and Physiology, you will stop being alive. So your thyroid helps you avoid such a fate by secreting hormones that that regulate many aspects of your body's homeostasis, like body temperature, skin moisture, and your blood's levels of oxygen, calcium, and cholesterol. It should come as no surprise that if the thyroid malfunctions and produces too much or too little of a hormone, it can lead to all sorts of weird and serious symptoms. And yet, thyroid disorders and the hormonal imbalances that accompany them are pretty common. It's pretty likely that you know at least one person, most likely a woman, who has experienced an issue with a dysfunctional thyroid, and many more of us are walking around with thyroid disorders and haven't even been diagnosed yet. In Marie's case, it turns out that she had Graves' disease, an immune system disorder that results in the overproduction of thyroid hormones, or hyperthyroidism. Although it's just one type of hormone disorder, looking at her symptoms can help us understand just how important, influential, and interconnected hormones are, and why they need to be properly balanced to maintain healthy homeostasis. And I cannot say this enough, homeostasis is life. Last time, we talked about hormone cascades and how a lot of the hormone activity that's bubbling along inside of you is the result of one kind of hormone bossing around the cells that produce another kind of hormone. These pathways typically start with an internal stimulus, often coming from the hypothalamus or pituitary gland, and end in the target glands that release hormones into the blood to get the real work of living done. We've seen how this kind of cascade controls your body's stress response through the hypothalamic pituitary adrenal axis, or HPA axis. Basically, your brain tells your hypothalamus to tell your pituitary to light a fire in your adrenal cortex, and in no time they've shut down digestion, released a bunch of energy, increased your blood pressure, and everything else you need to either fight or flee. And that's great! Your HPA axis is super useful when you are under stress and need to take action. But you do not need your adrenal cortex spouting off all the time. The truth is, much of the more basic, more fundamental business of everyday life is carried out by a different kind of cascade. It's the hypothalamus pituitary thyroid axis, or HPT axis, and it's what sets the thyroid gland into motion so it can regulate just about everything related to your homeostasis. For example, let's say you're caught outside on a cool day and you're underdressed. So let's say you were on a bus, busily texting your bestie, and you got off at a stop while searching for the emoji that most accurately depicted your reaction to the new Avengers movie when you realized that you'd left your jacket on the seat. There's nothing you can do to get your jacket back, but your hormones can do something about your coldness. Now, your nervous system, of course, has its own ways of detecting and signaling a change in temperature, but your endocrine system gets involved as soon as it senses that the temperature of your blood has changed. Your cooler than normal blood flows into your brain's hypothalamus, where it bumps up against temperature-sensitive sensory neurons, which act like a kind of thermostat. Once they detect that the temperature is below target levels, those neurons secrete thyrotropin-releasing hormone, or TRH, into the bloodstream. TRH is a tropic hormone, which means that it gets the hormone cascade started by triggering the release of other hormones. The cascade starts off with just a trickle, as TRH goes just a few millimeters to the anterior pituitary, where it hits receptors on cells there, causing it to release thyroid-stimulating hormone, or TSH, into the bloodstream. That then travels down to the thyroid, finds its receptors, and slaps the gland to attention so it releases its own special thyroid hormone into the blood, where it can affect virtually every cell in your body. Like steroids, thyroid hormone is lipid-soluble, so it crosses the membrane of its target cell to bind inside the nucleus. There, it can make the cell either increase, decrease, or maintain its primary function. In this case, since you're feeling chilly, your body needs to stoke the fire a bit, and it does that by burning glucose. In your cells, burning glucose really means breaking it down so its component parts can be used to produce ATP. Thyroid hormone comes into play when it binds to receptors inside the nuclei of your muscle cells, triggering the transcription of DNA that makes the enzymes to break down that glucose. With more of these enzymes flowing around, more glucose is being broken up and more ATP is being produced, which is all a long way of describing the process that we call metabolism. But since the thyroid has increased the amount of chemical reactions going on, it also increased the amount of waste heat that's being generated. So this process has a calorogenic or heat-producing effect that helps warm you up. Now, whether or not you happen to forget your jacket on the bus and found yourself shivering on the way to work, your thyroid hormone produces all kinds of other effects as well, like maintaining your blood pressure, promoting the growth of tissues, and triggering the secretion of digestive juices to keep food moving through your digestive tract, just to name a few. So, Thyroid hormone for the win, right? What's not to love? Well, what's important about the whole HTP axis is not just how it works, but also how it knows to turn off. Your glands need negative feedback in order to know when their job is done so they can stop secreting certain hormones. That's where your pituitary and hypothalamus come in. Remember, they're always monitoring hormone levels in your blood. If there's too much thyroid hormone, they both decrease their own hormone production to stop stimulating the thyroid. That, in turn, reduces thyroid hormone levels in the blood and slows down your metabolism again before you get overheated. At least that's what happens if everything's working the way it should. But there are millions of Maries out there, plenty of people, maybe even including you, who know full well that hormonal imbalances, thyroid-related or otherwise, happen all the time. Why? Well, thyroid disorders can be caused by lots of things, but in the case of our Marie, it's autoimmune dysfunction. Normally, when you get sick with a virus or bacteria or what have you, your immune system responds by sending out antibodies that target those invaders. Now, we don't fully understand why yet, but if you have something like Graves' disease, your body produces abnormal antibodies that target the cells of your thyroid gland itself. And instead of marking those cells for destruction like antibodies normally do, they do something even more bizarre. They mimic the hormones that the pituitary gland sends out, which bind to the thyroid's receptors. So even though the pituitary dials down its hormone production in an effort to get the thyroid to stop, the thyroid does not get the message because the receptors are still being activated. Basically, the gland never receives any negative feedback, so it just won't quit. And if your thyroid doesn't stop, it's hard for you to stop. So that's why Marie was always hot and sweaty. Her hypothalamus was screaming that she was warm enough, but those antibodies were hijacking the hormone cascade, and she was losing weight even though she was eating all the time because the thyroid hormone was no longer regulating her metabolism properly. But what about those big bulging eyes? Remember those? That was weird. Well, because they're part of the immune response, those disruptive antibodies often cause inflammation, particularly in the tissues around the eyes. In some cases, the swelling can be so severe that the eyes are no longer able to close. Treatment for Graves' disease involves either inhibiting the production of thyroid hormones or blocking their effects, basically getting your body chemistry back in order. The moral of the story is that hormones mean business, and by business I mean living, and by living what I really mean is, and everybody say it together now, homeostasis. In addition to learning to respect your hormones and thanking them for helping you live, hopefully today you learned something about chemical homeostasis and took away a greater understanding of hormone cascades. Specifically, we looked at the hypothalamus-pituitary-thyroid axis, or HPT axis, and all the ways your body can suffer when that system, or your hormones in general, get out of whack. Thank you to our headmaster of learning, Thomas Frank, and to all of our Patreon patrons who help make Crash Course possible through their monthly contributions. If you like Crash Course
and we do. We love Crash Course. We'll go back to where we were and stop sharing. There we go. Okay. Really, really interesting stuff. And it just scratching on the surface. A couple of things coming out of this was not only did we see the relationship between the nervous system and the tropic relationship back to the hypothalamus into the hormonal system, but we also saw a relationship between, when things get out of whack, the immune system and the hormonal system. So we're working all together, and it makes you really appreciate life. You know, when you think about the trillions of cells in your body and the fact that they're generating themselves all the time and making sure that they keep the body and together and then acting and living, you have these other systems in there to feed those cells, and making sure that we have the right food in our bodies is a really big component of trying to keep your nervous system, your immune system, and your hormonal system, your endocrine system, in check, and making sure that they stay in balance. And for those people who have had an issue with the balance of one or the other of these systems interacting with one another, or just inside the hormonal system, we can see that they're going to have issues, right, that we're going to run into as far as we relate to our business, right? And we need to make sure that we're getting the right nutrition into the individuals. And when we were talking about the neurons and the tropics and going into the hypothalamus and the controls there, the first thing that came to my mind was what product? One. Open up. What was the product? Okay. Answer is cocoprine. Right? Right? Because it's a tropic. You get the renewal of your neurons, right? You know, you go back to the issue of learning the product and you come back and say, well, holy macro, we need to make sure that we're tying this whole thing together. And then when we talk about the immune system, right? What are some of the things that we have in making sure that our immune systems are healthy?
Vitamin C, vitamin D,
Yeah.
hormone.
Glucagon. Yeah. The okay.
Glucosa.
Yeah. All the Cell Essentials products, right? Okay. So we want to make sure that we've got the right mechanisms to try to make sure that our cellular health is as good as it can be, because we have these very complex systems working with us. Now, we're going to go back in and we're going to see this fourth video. And I'm going to tell you that everybody hears things differently. So we're hearing the same things said differently by different voices and go for it. This next gentleman is a doctor and he has a Indian accent from India, right? So it'll take a little bit to adjust to your hearing and so forth and to receive what he has to say, but pretty much it'll reinforce, but say it in a different way, what we have just heard. Share screen. Go here. Gotta go backwards. There we go. And
The world is entering into an economic recession. Market volatility is at an all-time high, and that is when there's a huge opportunity in the market. Most people are learning to trade the stock market during this period.
Yeah, I know.
But did you know that the stock market daily volume of $84 billion is nothing compared to the Forex market daily volume of $5.1 trillion? That's 60 times bigger. I don't know about you, but I'd rather be a small fish in a big market than a big fish in a small market. It's just so much easier that way. Hi,
the
my
human
name is
endocrine
Justin
system
Ho,
consists
and I'm
of a
CEO
number
and
of
founder of Vincero Investment Academy. I have over 7 years of institutional trading experience.
And I've worked with major investment banks, including James Morgan, Morgan Stanley, and DBS Bank.
okay, something's gone wrong because I got two videos going at the same time.
Known as CFA.
You also have a different browser. Maybe just close.
Okay.
I want to invite you to my free online class where I'll reveal the exact system.
As a meeting leader, you can actually mute all your participants. It might be easier to do that.
That is the biggest capital return, very little risk. The system is easy to implement and follow, and over 300 students.
I can't seem to find what I'm looking for.
Have implemented my system and become successful.
Because I don't have this one running.
There are more millionaires
There's something going on
during
in
the
the background.
recession than any other time in the world because there's a wealth transfer going on.
Did you see another browser?
Position yourself for that transfer. With high market volatility, it opens up a
See, I got to get rid of what I've got on the screen.
to capitalize on. And you need a step-by-step guide to make sure you have
And
certain
show.
exactly what to do and to minimize your risk. And
And
here's
show.
why I'm doing this, even though I don't have to. When I first started my journey, I had no mentor to guide me. I made huge losses, and I paid a lot of gurus who didn't have the real experience to back up their claims.
So David, you can like close everything and then just leave the Zoom on. Maybe that works.
I need to build a system that works for me and has helped me to consistently beat the markets. And I was doing very good for myself. I had the freedom and the lifestyle that I wanted. But I always knew I could do more. Because my trading system requires very little time to manage, I spend most of my free time educating my friends who
Well, that didn't help.
and not living a fulfilled life. when I saw their lives getting transformed and having the
Well, it's not in
what they
YouTube.
want, who they want. It gave me a sense
David,
of
try close everything on your computer. Just leave the Zoom on.
working professionals about my training system so that they too can be free from the 9-to-5 job and the uncertainty in the market. All we have to do to sign up for this free online class is to click around this video, learn some basic information, and my team will send you the details of how you can attend this class. A word of warning though.
Or you could just close everything, leave the Zoom, and rejoin.
So if you don't want to
I'll
miss
have to
out,
sign back in.
register your spot
Yeah.
right now.
And maybe you could do that. But before you leave, make me a host first.
You are the host.
I'm not. Okay, the volume it went away.
Massive shortages.
No, that's not it.
Hi, I'm Chris Hurd here, and if you're like most people, you may have noticed some strange things popping up in the news lately. Because once again, the word crisis is being thrown around, and yet this is unlike anything we have seen before.
What is
Toyota are shutting down their factories.
Background voice.
No, but it may not happen this year.
So Zekla, what do you think about the Diamond University?
Don't know. I'm not there this year.
Oh, I just saw you. You had the super VIP
Oh, that's from last year.
for last year. Oh, okay.
The only one I got, so it's better than looking at the mess behind me.
Okay. Let me go back over here. So I'm back in, and I look like I've gotten rid of the things that I was interfering. So apparently I had too many video. I'd never closed out the old videos, and they just automatically decided to go back to doing their thing. So I have to open up my presentation again.
Don't worry. Oh, by the way, we have another new class line. She joined us today. Her
Oh,
name is Michelle. Welcome, Michelle.
all right. Welcome, Michelle. All
Hello,
right.
Michelle.
Thank you.
Slideshow.
Nice to see you.
Yeah,
Oh,
nice
I
to
can
see you
open the
too.
video. How?
Oh, hey. Nice to see your beautiful face. So Michelle,
Very good presentation.
so does the presentation make sense? Yeah, by the way, Michelle came from Chicago.
Oh yes, I'm from Chicago. All the Zoom is from different area, huh? That's
Yes.
very nice.
Yes, everybody's from a little bit of a different place. Okay. Now, Mila, we should be able to go back to the video without having to change anything. So we'll see where we're going now. Yeah, we open up. I need to.
Take your time, David. Hey, Lily, welcome you join us. How are you doing? You're unmuted if you want to open your voice, unmute yourself first. Yes, on the bottom of your screen, there's the unmute button.
Mine's on the top.
Yours on the top, okay. Mine's on the bottom.
So now it's good?
Oh yeah, there you go. Yes.
Okay, got it. Okay.
Welcome,
we've got-
Joanna.
So it looks like we've got a pretty good group. We've got Leonard, we've got Jishung, we've got Salem, we've got Mike, we've got Michelle, we've got Lily, Thekla, we've got Mila and Jishung, and myself. So here we are. And what I'm going to do is I'm going to go back to sharing my screen. Okay, can you see the slide presentation on your screen now?
Yes.
Yes.
Okay. And what we want to do is make sure we're more here. Okay, I'm still sharing sound, so that's still good. All right, so I'm going to go ahead and turn this thing back on.
Yeah. So Lynn just texted me. He said he had something he had to leave early. So bye, Lynn.
Oh, oh, where? Oliver.
This went so well last week.
So did we make me as a host or co-host?
Well, all right, I will do that again. I'm surprised that you're not, because make a host. All right, so you're the host, Mila.
Okay, perfect.
The hostess with the most.
Thank you. Yeah, every time when you disconnect, it come back up, and I lose the permission.
So what's stopping you from turning your dream life into reality? Believe it or not, there's a process and a formula for launching.
Skip left. Now we're going to go in.
In this video, we will study about the human endocrine system. Before beginning, if you are new to this channel, make sure to click on the subscribe button below to get all the upcoming of glands located all over the body that secrete hormones and regulate various functions of the body. Modern endocrinology originated in 20th century upon the works of a French physiologist, Claude Bernard, who made a key observation that humans have a constant internal environment which he called milieu interior, which is preserved by various systems of human physiology, including the nervous system, the immune system, and a set of glands that secrete chemical messengers known as hormones. The human body needs control over its cells, tissues, and various processes in the body so that it can function in an orderly and stable way, which makes the vital functions like growth, development, and reproduction possible. Now, this control is mostly provided by three systems in the body: the immune system, the nervous system, and the endocrine system. Now, the nervous system is in charge or control of various body processes that happen rather fast, like movement, breathing, etc. And while the immune system controls body's actions related to infections and damage.
Okay, what do you got?
We still cannot see the video if there's a video.
You can't see the video. All right, stop sharing.
Okay.
Okay, go back to share. Okay, go backwards. Right, hit play.
Yes.
Below. And for more information, watch till the end of this video. The human endocrine system consists of a number of glands located all over the body that secrete hormones and regulate various functions of the body. Modern endocrinology originated in 20th century upon the works of a French physiologist, Claude Bernard, who made a key observation that humans have a constant internal environment which he called milieu interior, which is preserved by various systems of human physiology, including the nervous system, the immune system, and a set of glands that secrete chemical messengers known as hormones. The human body needs control over its cells, tissues, and various processes in the body so that it can function in an orderly and stable way, which makes the vital functions like growth, development, and reproduction possible. Now, this control is mostly provided by three systems in the body: the immune system, the nervous system, and the endocrine system. Now, the nervous system is in charge or control of various body processes that happen rather fast, like movement, breathing, etc. And while the immune system controls body's actions related to infections and damage, the endocrine system in general is in charge of the body processes that happen rather slowly. For example, how fast the height of a person should increase, or maintenance of a constant level of electrolytes and ions in the blood, or body's metabolic rate, and various other numerous processes that we will talk about later. The human endocrine system consists of the following glands which are located all over the human body. We have the thyroid gland in the neck, which secretes important thyroid hormones which affect nearly all the cells of the body and maintain a proper metabolism of the body cells. Behind the thyroid gland, we have these 4 yellow parathyroid glands which secrete the important hormone parathormone. This hormone regulates the calcium and vitamin D metabolism in the body. Above the kidneys, we have the 2 important adrenal glands which secrete a variety of hormones that affect the metabolism of glucose, electrolytes, as well as they secrete the various catecholamine hormones, the adrenaline and the noradrenaline. We have the pancreas which secretes the important hormone insulin, which is important for the metabolism of glucose, fats as well as proteins. The reproductive hormone producing glands are very important and they differ in the 2 sexes. In the females, we have the ovaries which produce important sex hormones, the estrogen and progesterone, and in males we have the testes which produce testosterone. In the end, we will study the glands that control the secretion of all these glands, which are the pituitary and the thalamus, which are located inside the brain. Now let's look at a typical model of how most of this endocrine system works. So we have various endocrine glands which are able to sense about various processes of the body. These glands secrete hormones which act as chemical messengers that are then distributed to whole of the body through the bloodstream to initiate a specific effect. To put this into context, let's take the example of the pancreas. The pancreas, for example, secretes one of the very important hormones, the insulin. The pancreas has a rich blood supply through which it can sense the concentration of the glucose in the blood. Whenever we eat, the concentration of glucose in the blood rises, which is detected by the pancreas, upon which it releases the hormone insulin. This hormone activates most of the cells of the body to take up the extra glucose in the blood, which stabilizes the normal glucose concentration in the blood. Now, most of the hormones produced by the human endocrine system are of 2 types. We have the protein hormones and we have the steroid hormones. While most of them are the protein hormones, there are only few hormones which are of the steroid nature, which include hormones like luteinizing hormone, the follicle stimulating hormone, and testosterone. Now, these hormones, when secreted by a gland, are carried to the bloodstream and circulated in whole of the body. Now, some hormones affect only a specific part or function of the body. For example, testosterone, which affects only the gonads as well as the secondary sexual characters. While there are some hormones which nearly affect all of the human cells, which include thyroid hormones, which act on almost every cell of the body to regulate the cell metabolism. These hormones exert their actions on the cells by binding to specific receptors. Now, these receptors may be located on the cell membrane, they may be present inside the cell cytoplasm or even inside the cell nucleus. Once these hormones attach to their receptors, they exert their effect through different mechanisms, which lead to the effect of the hormone. One important mechanism are the ion channel receptors. In this case, the binding of hormone to the receptor causes opening or closing of one or more types of ion channels that regulates the entry or exit of one type of ions in the cell. Now, another very common type of receptors are the enzyme linked or the G protein coupled receptors. In this case, when the hormone binds to the receptor, it causes the activation of many enzymes in the cell which exert the effect of the hormone. We also have gene-linked hormone receptors where binding of the hormone to its receptor in the nucleus causes activation or deactivation of a transcription factor of a gene in DNA. Example of this is the steroid hormones, which increase the transcription of genes which are responsible for increased protein synthesis in the cell. So first of all, we will take a look at the thyroid gland. The thyroid gland is located immediately below the larynx and it is one of the largest of all endocrine glands, weighing about 15 to 20 grams. The thyroid gland secretes 2 important hormones, the T4, the thyroxine, and the T3 or the triiodothyronine. 93% of all the secretion of the thyroid gland is the T4 and only 7% of the secretion is T3. Thyroid hormones require iodine for their synthesis in a dose of 1 mg per week. These hormones are protein hormones that bind to their receptors, which are mostly located in the nucleus or the cytoplasm of the cell. After that, the thyroid hormones have hundreds of effects on cells, like increase in the number of mitochondria of the cell, increase in the carbohydrate and fat metabolism, and increased activity of the various ion channels of the cell membrane. It has many systemic effects like increased cardiac output, increased heart rate, and increased CNS activity. In short, we can say that the thyroid hormones are important in a way that they regulate the basic cell metabolism and activity which ultimately affects the body as a whole. Now, the second gland that we will talk about is the parathyroid gland. It is called parathyroid gland because it is located just adjacent to the thyroid gland or behind it. We have 4 parathyroid glands, one behind each of the upper and lower poles of thyroid. The parathyroid gland has a vital function of regulation of a constant concentration of calcium and phosphate in the body. It does so by releasing a hormone known as parathormone, which mainly acts on bone, intestines, and kidneys. Through the intestines, it regulates how much of the calcium should be absorbed in the body. Through the kidneys, it can regulate how much should be excreted, and since bones are a large reservoir of calcium and phosphate, it can use that to increase or decrease the calcium and phosphate concentration of the blood. The next endocrine organ that we will briefly discuss are the adrenals. Now, these glands are called adrenals because they are present just adjacent to the kidneys, sometimes also known as the suprarenals since they are located above the kidneys. Now, if we take a look at the cut section of the adrenal glands, we can see that it is made up of different sections. On the outer side, we have the adrenal cortex, and at the central part known as the adrenal medulla, and both of these parts secrete different types of hormones. Now, the adrenal cortex has 3 layers or zones, which are Zona glomerulosa, which is the outermost layer. We have the Zona Fasciculata, which is in the middle, and then in the inner side we have the Zona Reticularis. These layers secrete different hormones, and these can be remembered by a simple mnemonic, the GFR, which stands for these layers. Now, the outermost layer, the Zona glomerulosa, produces the hormone aldosterone, which is a mineralocorticoid. Aldosterone mainly acts on the kidneys to maintain a constant level of sodium, potassium, and other ions as well as fluid balance of the body. The Zona Fasciculata, the middle layer of the adrenal cortex, mainly synthesizes cortisol, which is a glucocorticoid. Cortisol is essential for life as it has permissive actions on multiple organ systems as well as metabolic processes throughout the body. Now, cortisol is essential for your body to have a proper stress response. It is essential for your body to have a proper metabolism of glucose, fat, as well as proteins. It is essential for important normal BP regulation and normal immune system regulation. Now, the innermost layer is the Zona Reticularis, which secretes androgenic hormones like the dihydroepiandrosterone, which are important for the development of secondary sexual characters. Now, the inner side we have the adrenal medulla, which can be considered as a part of sympathetic nervous system. It releases the catecholamines, epinephrine and norepinephrine into the general circulation. It is activated when the sympathetic nervous system is activated, and it is essential for the classic flight or fight response of the body. So this was the first video on the series on endocrinology. Make sure to watch the second video on this series. The link will be in the description below. In the second video, we will discuss about the rest of the endocrine glands, and we will also talk about the control of these endocrine glands by hypothalamus and the pituitary gland. Guys, thank you.
Okay. Super. So stop sharing. There we go. We get back to what we were doing. And what I want to do is to go back to share, but I want to go back to the briefing slides. So hang with me. I'm going to kill this. Make sure it doesn't interrupt with us.
So David, we're going a little bit over off time, but do it as fast as you can.
Okay. I will do this as fast as I can. All right. So basically, we learned that today that hormones are chemical transmitters. They're released from our glands, right, into the bloodstream, and they go to target cells, and they do various different things. We also learned that there are a lot of them. There it is. Okay. And basically, you said the same thing just then. And this little picture here gives you the location of the various different cells. And that what we want to do is to say that the diet is important when it comes to your hormones, because we need to feed the systems properly, get them the right nutrition so they can do what they need to do. One of the very interesting things from this last presentation was the fact that iodine was important, and he actually gave us the amount of iodine that was important in the presentation. But what you need to know is that our scientists at USANA have already figured that out and have included these things that we need to have into our cell essentials. And you will find that the proper amount of iodine is actually in the product that's there. Now, what I was going to do as we go forward with this has been the orientation to the endocrine system. And what I want to do now is I want to look at each gland and the hormones that are associated with those glands in subsequent weeks' presentations, to be able to not just talk about what they do, but what happens when they don't work well, and how that can then affect people. And then, okay, how do you then recognize those issues, right? And where do you go with it? And then how do you recommend the right nutrition to help them with their situation? Now, we've seen components of this in various different parts of of it. We talked about the neuron and the hypothalamus, and we talked about the coprime, we talked about iodine, and we talked about the cell essentials. And we have also touched base on the need for protecting our systems from inflammation with the proflavin C and the other components of it. The intent is to go through and recognize the various different components of hormones, as well as hormonal imbalance, right? So that we'll be better able to talk with our clients about things that they're most interested in, and then being able to recommend the right nutrition for them. And then as we go back through that, then we're going to get into these the various different hormones, and then we can then correlate that back into various aspects of intimacy as we go to the culmination of the series of discussion. So again, from relationship to intimacy and the health that is necessary to go through the system in order to have that healthy balance of life and happiness. All right. So that wraps up tonight. What have we got in the way of questions?
So I have a question. What's HPA again?
Yeah.
You say XPA?
HPA, yeah.
The axis, yeah. The hypoparathyroid axis. Okay, and that goes back to parathyroid axis is the thyroid with the parathyroid, and then you have the parathyroid controls calcitonin, which then controls the amount of calcium in your bloodstream. So whether or not you're putting calcium into your bones, or whether you're pulling it out for your bodily functions, for your muscles and contractions and so forth and activities, that's the parathyroid that does that.
That's awesome. And
I'm low on calcium. I don't have any builds up.
Well, we do know that in the magnecal D, right, magnesium and calcium and D supplement that's in our health pack is incredibly important, because it provides the mechanisms for this calcitonin to act, to be able to make sure that we have calcium for every muscle contraction and magnesium for every muscle relaxation, as well as the storing of calcium in our bones to keep us from having bone problems as we age, as well as then keeping the calcium in solution so it doesn't build up on the inside of our arteries.
Interesting.
Yeah, so it's a heck of a dance.
I know.
It is.
All right.
And
So
you said, how many hormones are there total?
there's like 100, 120 different hormones, and there are different combinations of different hormones. And then, going through, but we talked about there being about 50 active in your body at any one time.
That's so many. I was thinking just one type of hormone, but I realized, oh wow, more hormone, like the more countries.
Well, we're as was said, we're all hormonal all the time.
Mm-hmm. Awesome. So next week will we study?
Yes, we're going to go and study individual glands, and I think that what we need to do is we need to start at the top and work our way to the bottom, which would then give us the hypothalamus and the pituitary gland as a starting off point. Now, we were introduced to that today, and we should be able to get into that a bit more detail. And then the parathyroid and the thyroid would then follow, right? And then we'd go into the adrenal gland, into the adrenal and the pancreas. Okay.
Awesome.
Now we have talked about these things, but we talked about them in a different context. And now what we want to do is we're going to talk about the gland, and we're going to show the relationship back to the context that we talked about, and then draw upon, okay, what is the particulars of the nutrition that is needed in order to take care of that particular gland. And I don't want to confuse or worry anybody about the complexity of this, because quite frankly, this is where Ask the Scientists and our dear friends in the R&D offices of USANA have really done yeoman's work. I mean, they have really put together amazing science into the products that we have. And given the fact that we have more and more times that the Consumers Lab is approved and certified the products, we know that the products that we're getting are exactly what our scientists have told us we're getting.
Yeah. Awesome.
Okay. So
the reason why we're so much above all the other brands.
Yes, that's one of the reasons why we're so much above all. If you have done any research into anybody else's products, they do not have this scientific basis. They're just stealing other people's work and trying to put together, as Dr. Wentz said, in his presentations in 2012 and 2014 and so forth, talked about people just trying to put together the same ingredients that are on the label of the Cell Essentials and calling it their own product. And quite frankly, if you don't get everything right, you don't get the purity right, you don't get the concentrations right, you don't get the formulations right, okay, you're not going to get the same product. And that's what we can have a lot of pride in the fact that our scientists are that, and the fact that USANA is a scientist-run company, okay, and that every time that there is a change in the science, we see a change in the products.
Mm-hmm. Yes.
Okay, so who's there? Mike, thank you for coming again. Did you have anything you wanted to add?
Michael.
No, sorry, I was driving, so I was muted, and I just got home. It feels like it's a really good biology review from like years ago. So, and it's I think it's important to know about these glands because they really do affect our body, and how it relates to USANA. I think it's kind of cool.
Yeah. Okay. And Michelle in Chicago. It's so cool because
Hi, how are you?
it's
Sorry.
so cool. I'm so glad you could be here. I mean, we're all across the world today, and
Nice to see
so,
you.
yeah. Do you have any questions, or you have anything you want to add to the conversation?
Oh no, that's very great. Thank you.
All right. Okay. So Salem, this is your first time at one of our presentations, so welcome very much. I know that we've chatted before. We do have an answer for your question that you asked on Facebook, and either Mila or myself will reach out to you and talk to you about that. So do you have anything you want to add to today's presentation?
Just that it was really good to get to go over all of this. I agree that it was like going over my honors biology class in high school. But it was really interesting, and I'm interested to learn more. I'm gonna probably start coming to these more often. Unfortunately, I wasn't as engaged as I wanted to be today just because I've got a lot of stuff going on, but I really enjoyed hanging out and hearing stuff.
All right. Well, yeah, thank you so much for coming, and we'll be back in touch with you on your Facebook question. And who else have we got left here? Thecla, did you want to add anything? I know you've got personal experience with this.
Yeah, but not this time.
Okay. Lily, welcome back again. And Lily's out there. Okay. There we go. Hi, Lily.
Hi.
Okay. How you know, the presentation, how did you like it? Is there something you want to add to it? Some question you want to ask?
No more. No yet.
Okay. All right. We'll get to that and talk about the various different things that are hormonal that affect you as we go into the presentation. And then Jisheng, Mila, would you ask Jisheng if she has anything that she would like to contribute?
Okay. 阿香，你还在吗？如果你在的话，可以把你的镜头打开。然后，就今天的话题主要讲的是荷尔蒙的健康。如果你有任何的问题，也可以问他，我可以帮你翻译。你的话筒没打开。
我现在还没有什么问题。
好的。对，他今天讲的主要是生物方面，就是因为总共有150多个荷尔蒙都会影响到各个方面的健康，比如说你的骨骼健康，你的身体的各个部分的健康，所以他今天讲的是稍微深奥了一点，可以很难理解。没关系，他这个是有几个步骤，所以还有第2章、第3章。好，那我稍后跟你沟通吧。
Okay.
Okay. Jishan doesn't have any question for now.
Okay.
It's very complicated for her.
Right.
I imagine.
How about Jishi? Does Jishi have anything? And then we'll wrap it up.
That's good. Everything good.
Everything's good. All right. So that being said, then next week we're going to touch on and develop this conversation with the hypothalamus and the pituitary gland, and we will talk more about the implications of the hormones and the unbalancing or the effects of the becoming unbalanced in the hormones. And we saw that was pretty easy to do because of the cascading events and the interaction between the immune system and the nervous system. So thank you so very much for coming, and we'll see you next week. Remember, it's always at the same time and the same number and with the same password. So